Hi everyone, welcome back to Teradata Developer Training Series. In our today's session, we are going to learn about introduction to Teradata. So what is Teradata? Why do we need this Teradata? So how this Teradata will be used in our data warehousing environment, and the Teradata architecture. So what is AMP, what is Node, SMP and MVP architecture. Then we are going to learn about primary index concepts. If you haven't subscribed our channel, please subscribe the channel and click on the bell icon so that you'll be getting all the notifications. So let us start our session. Step is architecture. The second one is like SQL. Third one is like the utilities. Okay, utilities, and also practical experience on the things which are available in day to day, whatever we are practicing it, right? So even if you're having any doubts on Teradata, you can ask me. So if you have a very good experience on the SQL, then Teradata is very easy only. The thing is, the architecture wise, we have some differences. So those things we have to learn, and then creating the table also we have to learn some different things we have to learn. Okay. So first 2 to 3 days we are going to see like a theoretical class only. After 3 days or 4 days, we are going to see that completely on practical, creating a table, creating the utilities, all those. Okay. So my suggestion is take one notepad and pen. Okay. So whatever I'm teaching it, you can make a note of it. So this is what the agenda for today. So just we are going to see that introduction of Teradata and Teradata features, all those architecture, everything, how it will be the indexing, how it will be the storage, all those. The next session we are going to see that utilities. It's like a space, all those. Okay. So you know the Teradata, right? So why the naming call it as Teradata? So this is the first database in the database environment. It's the first database. We will call it as it handles the data in terms of terabytes, 10 to the power of 12. So in 1970s itself, they have started in California, and this is the first database handled terabytes of data in the year of 2000 in the era of 2000 handle the terabyte of data. So now the big data environment, they are handling it like petabyte, but this is the first database handled the data with the terabytes of data. Before Teradata, right, it was named as NCR Corporation. Okay, so that is the only company they have developed first. After that, Teradata has the company is acquired by Teradata, and from there they have named as Teradata Corporation in 2007. So that is what they have formed the Teradata Corporation. It is an American-based company. Okay, it's headquartered in California that they are operating. So normally Teradata, they mainly meant for data warehousing applications. Data warehousing applications, you know already data warehousing, right? So data warehouse is nothing but it is used to handle huge volume of data. The historical data we will have here, we'll have our OLTP system. Instead of fetching the data for reporting, the OLTP, we have developed one system called OLAP. So this is like OLAP is for to handle huge volume of data. Why? Because, for example, if I have a company, to have the company analysis from the first day to till date, like last 5 years, last 10 years, or last quarter, last month, or last year, if I want to analyze it, then it has huge volume of data, right? The data should be handled. If I'm having only this OLTP, if I go and fetch the data for reporting, then this OLTP will get impacted. So that is why the company will have OLTP separately. They will not disturb this database. Normally OLTP, they will kept it in Oracle database. Whatever the transaction we do, right? For example, if you have online transaction, IRCTC or Amazon or Flipkart or anything, right? So whatever we are ordering it, everything will be handled by OLTP system only. Everything will be handled by OLTP at every frequency of time. We will fetch the data from here and we will load it into the OLAP. So for OLAP, for reporting purpose, it's for only for the management people. The management people, they will take report from this OLAP. Why? Because they should not take, for example, if you take Amazon, right? Amazon per second order is 800 orders per second. Think about 1 hour order, how many records will be created. So one order will create the backend 20, almost 20 records, the backend, approximately 20 records. But think about 1 minute record, 1 hour record, 1 day record. How many volume of record it will be created? So if I'm going to fetch like last 5 days of sales, it will be, this system will get impacted. To avoid that, we should not affect this particular system. To avoid that, we are every like half an hour or 1 hour frequency, we are pulling the data from here and loading into a OLAP system. Got it? OLAP system. So from there, I'm pulling the data for reporting. This OLAP system should have the capability to handle huge volume of data. So that is why we are going for Teradata. We are going for Teradata. Why? Because it can handle the data in terms of parallel. Okay, instead of in Oracle, it will be a serial, right? Serial of data access, it will be supported. But in Teradata, it will be parallel. So we have a process called AMP, so access module processor. So we will have multiple AMP on the Teradata. So it will be processed. So that is why the companies are going for Teradata for their data warehousing applications. So from this warehouse only we are going for reporting like Tableau or ClickView or all those. So this is what the introduction of data warehousing, why they need data warehousing on Teradata. So that is why so multiple business will fetch the data from the data warehouse. So that is why the system should withstand this only for reporting purpose, not for the day-to-day business. This data warehouse, we will create it only for the reporting purpose. So if you take Teradata, we have different product from the Teradata Corporation. Okay, these are like data warehousing, database, okay, columnar database. So we have different utilities, right? So a lot of utilities are available. So application side, we have a lot of like Teradata marketing operations. We have applications also, Teradata. Even Hadoop also we have Hadoop environment, Teradata application for Hadoop. Okay, big data environment also they have improved on nowadays. See here, big data analytics and Hadoop services. They have already started the services. That is why that the Teradata is used by the large enterprises, not for the small enterprises. And also the cost of Teradata is huge. Only the large, those who are handling huge volume of data, they will go for Teradata for their applications. And this is what the Teradata stands for, like with all the applications. Like nowadays, instead of Teradata, they have come up with big data also. But anyhow, it is on the, whenever we are going for huge volume of data, they are going for some Teradata applications. So we have different versions in Teradata. So normally Teradata 16 is the current version we are using in real time. So this is what the history of Teradata. 1979, they have introduced first Teradata, the database. This is the 1999 only. They have handled 130 terabytes of data. So this is the first database to handle 130 terabyte in 1999 itself. So even nowadays, some of the companies, right, they have data warehouse only on terabytes, like 130 or 1000 terabytes, all those. Okay. In 1999 itself, they have handled 130 terabytes. So 2008, they have introduced Teradata 13. Then 2012, they have introduced Teradata 14. Then 2014, they have introduced Teradata 15. And now 2016, right? December 2016, they have introduced 16th version, Teradata 16th version. So as of now, we are using Teradata 16. So these are all the main features in Teradata. The first main feature is parallelism. It has the architecture of MPP architecture. MPP is nothing but massive parallel processing. So it will do the parallel processing of massive data. So that is why we will call it as MPP architecture. And shared nothing architecture. So we will call it as Teradata architecture is shared nothing. I will tell you what is the shared nothing architecture after some time. It will have the horizontal scaling, not at the vertical scaling. It will have the horizontal scaling. So if any one of the node has been failure, the other node will take care. That is called a shared nothing architecture. For example, the data, I will tell you what is that shared nothing. Normally, we will go for this is, if you take, this is my database. This is my database, okay? Now it has something like 500 terabytes of space. You assume that it's a 500 terabytes of space. you want to increase 100 terabytes more. So normally if you are going for increasing it here, okay, it's like vertical scaling. Now it will be at 600 terabytes, it will be vertical scaling. Instead of that, if you are going for vertical scaling, what will happen? If this particular system get hanged or something happen, all the 600 terabytes you cannot get it. We will call it like system halt. Then we have to restart it, and then we have to check some troubleshoot method to bring it. But if you're going for horizontal scaling, for example, whenever we are going for horizontal scaling instead of vertical, whenever you want to add it some 100 terabytes, you go for horizontal scaling this way. So
Okay.
this is like a box, Teradata box, a complete Teradata box we will have. Within the box we will have multiple node. So node we will have. So each node will have the space, okay, Teradata space. So each node, assume that 500 terabytes of space. If one node has been failure, then whatever it has handled, it will pass that activity to other node. So this is like whenever this node, the failure mechanism we will see after some time. Whenever the node has
Okay.
been
Then what
going,
about the data in that node? Is there, will it be there any replicas of that
yeah,
data in
definitely
the
we
other?
need to go for replication. So we will have the replication before that also. We have the fallback table, right? Fallback table, or so whatever the node
Okay.
replication factor we will have, we will define that replication factor in the Teradata box itself. So whenever it is storing the
Okay.
data into the one node, it will replicate that data, same data into a different node. For example, by
Oh.
default, the replication factor will be 3. If I'm
Mhm.
going for replication factor will be 3, the other 3 node will have that, other 2 node will have the same data. If this
Okay.
node has been failure, the other node will take care that activity. This is like a fault tolerance. I will explain that data protection method. Okay. So this is like shared nothing architecture. If any one component has failure, the other component will work on. Why? Because it's an independently work, right? It is not
Yes.
dependent on the other one. So if it is here, it is failing. So entire it will get failed. But here it is failing. Whatever the activity it has been handled, it will be transferred to the activity to the other node. And other node will take care. Then they will go for the. This is like hard standby node. Okay. Hard standby is nothing but whenever a node failure, the other node will take care of that activity, whatever the activity is handled, right? The other node will take care. It's like a stepney in the car. Okay, this is what it will take care, and each component in Teradata it will work independently. So that is what the shared nothing architecture and
Understood.
linear scalability. So this is what the linear scalability. We can go for linearly the horizontal scalable, right? Whenever we need to have the space, we can go for linear scalability. It can be scalable up to 4096 node. Now they have
Yeah.
improved to 4690 nodes. So
Mhm.
like this, they can go for linearly, they can go for 4096 node. Okay, parallel. And then connectivity, they have Teradata connectivity, they have the BiNet, right? So BiNet, it is a software and hardware component. So for the connectivity, they will use BiNet. BiNet will connect, it will interact with each other node and also internode, node also. And we have the optimizer. This optimizer will tell us where the active data is present, and then whatever the data we are frequently accessing it, it will handle that. The optimizer will do that, the access path, everything we will see that. Okay, so SQL, it will follow the ANSI standard. No other standard it will follow. So it will, the Teradata will follow that ANSI standard, so it will be faster. Okay, so we have different utilities, right? The distribution, the data distribution will occur automatically based on the AMP we are choosing, number of AMP. Based on the indexing, it will data will be automatically distributed with other AMP. So this is what the feature of Teradata we are going to see in detail. So as I told, we have a lot of utilities are available. So either you can import the data or export the data from the database. Okay, so you are importing or exporting data from or to a Teradata. Okay, you can import it or you can export it from the database. So from flat file, if you want to load it into the Teradata, you can go for fast load. So if you want to load multiple tables at a time, you can go for multi-load. It's a T-pump. It's you are loading the data into a Teradata. Fast export, you are exporting data from the database. That is what the fast export. Okay, TPT, it's the Teradata parallel transporter. We will see one by one after some time. The utilities. So these utilities we will see, then you can understand clearly. the Teradata architecture, right? This is what the basic architecture of Teradata. Like this is what the architecture of Teradata, I think you have seen already. So it has four major components. One is parsing engine, binet, AMP, and storage. Okay, disk. So normally this is what the architecture of Teradata. I think you are familiar, but I will explain. The parsing engine is like a gatekeeper. Okay, so from the database or to a database. So whenever you want to take data from the database or you want to store the database, this is the first person to check your authentication, whether you are the logon. It will check your credentials, everything, and then it will parse that particular query. Whatever you are giving that SQL query, right? Select star from something. It
Yes,
will
yes.
convert that SQL query into a machine readable language, and then it will give it to the database. Okay, and also it will check the logon. So very first time it will check whether you are the authenticated user or not. It will tell that okay, it will pass on to the next over. Then parsing engine, and then it will check for the access path also. You are running the same query again and again. It will
Mhm,
it will store that query into one particular place. Okay, the access
mhm,
path it will place, and then you are fetching the same query. So anyhow it will store it in the RAM, and then it will fetch that query easily. So that is what the
mhm,
activity of parsing engine. Then you have the binet. Okay, so binet is nothing but Banyan network. It is for the connect. It's a hardware and software component on top of the wire, right? So within the database, we'll have some hardware component. On the top of the hardware, we will have some software component. It is used to do the communication between the modules. Okay, the modules component. And the AMP is nothing but it is the processing engine. Okay, it is a processing engine for Teradata. So access module processor is the acronym by for the AMP. So this is for the parallelism. Okay. So based on my index, it will distribute the data so to the data storage. Where it will be stored, the data how it will be stored, and it will keep all the information for the storage and as well as retrieval. It will be important. You have stored today. After some time you want to retrieve, right? So for the retrieval, it should tell that where it has been stored. So whether the data is there in the disk 1 or disk 2 or disk 3 or disk 4, it will have all this
mhm,
information. And also whenever you are doing all the arithmetic operations, like
mhm,
the rank or arithmetic operations like the minimum of, maximum of, sum of, the calculations you are doing, right? All the
mhm,
calculations done by using this AMP only. This AMP
mhm,
only. Then storage, it is used to store the data. So if you look at the storage, it will be a one hard disk only, one single
mhm,
database only. The single database is subdivided into logically. How we are having like C drive, D drive, E drive, right?
mhm,
It's a logically divided, but it's a separate component. But if
mhm,
you check the hard disk, it's one single component. Okay, the database is one single component. So you know, right? So if you take a database, the entire database, or sorry, Teradata database. So within database, you will have multiple databases. In Oracle, we will call it like a schema. In Teradata, we will call it as database. Like in our real time also, we'll have different databases. If you are working for one particular database, this database only you will have access. The other databases, you need to get access based on your role. So you'll have, so if you want to check how many databases are there, you have to go for DBC. So DBC is nothing but it's a metadata table. It will be mostly used for Teradata developer database computer. So that is the abbreviation for DBC. dbc.tables, dbc.tables v. So we will have one session on DBC also. Okay, how many different tables are there on DBC? We will see one by one. So that you can get that metadata tables, you can have the idea on DBC. So this is a logical division of storage. The data will be stored in different disk based on the fallback, whether it will be stored here or the replication, it will be stored on different storage. We will see on the replications. Okay. So this is what the Teradata architecture. While inserting the data or while how many the parsing engine needed for this particular database, how many AMP is needed, it's based on the number of node and also the number of AMP they are using it. So this will be taken care by Teradata admin. It will be taken care by Teradata admin. But for example, if you have 6 rows of data, it will not store in a single storage, in single disk. If you have 3 different disks, It's all about unique primary index. We are using it. Then record will be stored in different disk only. Okay, if the row is 1 is coming here, row 2 will be going here, row 3 will be going somewhere, row 4 and row 6 and row 7. So this is what it will go. So this is what data storage as well as data retrieval. So this is the abbreviation for all those. MPP is nothing but massive parallel processing. AMP is nothing but access module processor. PE is nothing but parsing engine. SMP is nothing but symmetric multiprocessing. Okay, symmetric multiprocessing. This is one symmetric multiprocessing. This is one single SMP. Okay, the combination of this SMP is called it as MPP. Okay, combination of SMP we will call it as MPP architecture. One SMP may have multiple AMP, the parallel processing. Okay, here for the pictorial representation we have only given 4, but in real time you can check how many AMP is there. We have one query. Okay, the database you can go and check how many AMP is there for the particular database. Okay, I will give you that query for that to check the how many AMP is there. And then BiNet is a banded network. bteq is nothing but Teradata basic query. So this is what bteq script we have. So this is what the introduction. So now we are going to cover the different. So whatever I have told is a single data store only. Single data store, but logically divided. Okay, logically divided. So horizontally scaling and parallelism can handle the parallelism, and the parallel load and utilities we have. Fault tolerance, I told right, the shared nothing architecture, and total cost of ownership. We will say like it's a low cost for setting up, but it requires huge. The cost is huge only. We will call the Teradata. We will call it as low cost, but the cost wise when compared to other database, the cost wise Teradata is costly. The business intelligence we will go for data warehousing, right? Star schema, Snowflake schema. We'll go for Teradata, and we will call it as intelligent memory. Okay, so Teradata we will call it as intelligent memory. So what is that intelligent memory? Whatever the data we are frequently querying. Okay, so frequently querying, that the data will be automatically stored in the RAM of the disk, the database. The access path, it will be easily maintained, so it will easily fetch the data. So that is what intelligent memory we will call it as for the better performance. So this is the architecture of one particular node, one SMP. I told right, one SMP, and we will see each and every component now. SMP is nothing but symmetric multiprocessing. MPP is nothing but collection of SMPs. So this is one single node. This is one single node. Here we have 4 AMP, but in real time we have multiple AMP. You can check how many AMP is there in your database. You can query that. I will give you some the metadata query to query the database, and you can check it. Okay, and then SMP. SMP is nothing but this is one single SMP, single node. We will call it a single SMP. Then if you connect all the SMPs in the Banyan network, the BiNet, for interconnectivity of the node, then we'll go for MPP architecture. Okay, this is called MPP architecture. So MPP is nothing but it's a horizontal scaling. We will call it as cluster of database. If one in the cluster, if one node has been failure, the other node will take care. So whatever the task is has been handled, it will be given to the other node. The other node will handle it, and then Teradata admin team, they will restart this particular node. Then they will bring it up this particular node. Then it will take care the activity. After bringing up, it will act as a hot standby node. This is what the architecture. If you look at the architecture, we will call it as virtual processor. Okay, so vproc. So vproc is nothing but, see here, this is what the virtual processor. So one virtual processor used for the parallelism. Okay, the virtual processor is nothing but parsing engine and AMP. The combination of parsing engine and AMP is called it as virtual processor. So this one we will call it as virtual processor. vproc, the parsing engine and then AMP. So this is like one virtual processor, vproc. So sometimes we will call it as vproc. What is that? So vproc is a combination of parsing engine and AMP. So what is the functionality of vproc? To read the data. Okay, so read the data from the outer world to Teradata, or Teradata to outer world, read and write operations. Okay, and then sorting. So while storing the data, if we want to store the data in the sorted order, then it will do the sorting algorithm, building the indexes, indexing, and loading the data into the database, and aggregations. I told, right? The AMP will take care of that aggregations, transactions and journaling, backup and recovery. The transaction and the journals and the fallback, backup, I will tell you after some time. What is that? The combination of vproc, we will call it as one single unit. Multiple vproc will be available. This is one vproc. The same way, this is another vproc, another vproc, another vproc. So the combination of vproc will be called as one node. The node will be called as MPP architecture. So this is what is the basic activity of vproc. It is used to do the parallelism. The multiple vproc will be available to handle that parallelism. Instead of doing one particular task by one person, the task by divided by into multiple persons, then it will be easily carried out. So this is what the virtual processor. Then what is the functionality of parsing engine? I told, right? Parsing engine is the gatekeeper of the first one. From the client to the database, the parsing engine is the gatekeeper. Okay. So it will act as a communicator between the client and the database. Client and the database through the AMP, and Binet. Okay. This is the parsing engine. The main activity of the parsing engine, the session control. It will check the log on and log off, authentication, all those. So in the bteq script, you are checking like log on, right?
Yes.
bteq script, first you will do the log on. First, if you are running the bteq script, the parsing engine will check the log on. Okay, whether the system is having that either sometimes a system account also may get locked, or system account may be expired. So that time, the parsing engine itself, it will stop that. Sometimes whenever you are executing the job and right, you will be getting error. Your session has been expired. The logon has been expired. So that time it will not go into the database also. The parsing engine itself, it will authenticate and then it will tell you what is error. Then the SQL parsing. SQL parsing is nothing but if you are giving some joins or subqueries, so you are giving some select star from something, right? It will convert that select star from into a machine readable language. The parsing error handling. If your query is having some error, some syntax error or logical error, it will throw. Logical error, it will not throw. The syntax error, it will throw. The parsing engine itself, it will identify that syntax error. It will not go into the database also. So error handling. Execution plan. Execution plan is nothing but, so how can I execute this particular query? Okay, so in which way? Execution plan. So you are executing the same query in daily, right? It will store that execution plan in particular place. If you are running the same query on daily basis, daily it will not check the execution plan. So one time it will check the execution plan and then it will store it. Next time it will have the hash value. So based on the hash value, it will take that execution and then it will proceed with that execution plan. Then dispatch that query into a AMP. So whatever we are passing that query, right, it will dispatch with the AMP. So particular AMP. Then it will proceed with the result set to the client. So this is what the functionality of parsing engine. Got it? Then the Binet. Binet is like a Banyan network. This is what we will call it as high-speed interconnected network. Communication between all the nodes and everything. So linking the vproc nodes, signaling messaging, we will go for Binet. Then we will go for AMP. AMP is nothing but access module processor. Like each and every AMP is the main processing unit for the arithmetic operations. So virtual processor, the vproc, right? In the vproc, this is the main component. Okay, manage the database, handle the file task, manipulate the task, all those it will be handling it. You have the locking system, right? So you will have the table locking. If you want to read that data from the table, you will make it like read lock. If some process is writing data into a table, you will go for write lock. Then no other will at the same time they cannot do the write into the table. Okay, read lock, write lock we will do, and then you can we will see that what is that locking system, and then joining, sorting, aggregations, journaling, the space management, everything will be taken care by access module processor. Then storage will be taken care by storage, and we do have one the software component, we will call it as PDE. PDE is nothing but on top of our OS, right? For example, in real time, on top of Linux OS, they will be installing that Teradata. The Teradata need to communicate with the OS also. The Linux OS and then Teradata, it needs to communicate on database. So that connectivity, this PDE will give us that connectivity. Parallel database extension will give us the connectivity between the OS and the database. Interaction between OS and
What about Windows? On Windows, we can run
Windows.
this.
So here I have installed on Windows, right? But in real time, it will be installed on Unix only, not on Windows. So Windows, we have only the client. For example, this is the database server. This will be mounted on Unix OS. This will be mounted on OS, right? In our system, it will be mounted on OS called Windows OS. But in real time, it will be mounted on Teradata has been installed on Unix or Linux or Red Hat, all this Ubuntu, all the operating system. Okay, any one of the operating system. The interaction between the OS and the database by taken care by this PDE, parallel database extension. So now we will start with the indexing. So I told the data has been distributed, the automatically distributed. The features also we have seen, parallel distribution will take care that automatically, right? How the data will be distributed automatically based on the index only. Create index, or you may not create index. Teradata itself, it will automatically create an index for the table. First column, it will take it as a indexing column. So sometimes in our real time, if you don't create indexing, it will take it as no PI table. No PI table. No PI is nothing but no primary index. So in our database environment, they have set up like if you don't mention any primary index, you take it as no PI table. In our environment, they are using like no PI table. So nowadays they are using like no PI, but it will be differ from project to project. In your project, they might be using the first column as primary index. In our system, right? If you don't use that primary index, first column will be taken as primary index. So you assume that you have the data. So you have the data in the table, some data in the table. Based on the data, it will be distributed. Okay, it will be distributed. So you have customer table. Assume that you have customer table. You have customer ID. So assume that you have unique customer ID. So you have unique numbers. Okay, unique numbers. You want to store this data into a database. So each and every record is unique, right? So based on that Unix value, it will have some algorithm to divide that data into a different AMP. Okay, something like modulus function or something, it will have it. If I have 4 different AMP, then this will be divided into 4 different the AMP. Okay. So it is going to AMP 1. Okay, you assume that this is going for AMP 1. This will be going to AMP 4. Okay. This will be going to AMP 4. This will be going to AMP 3. Then again it will be going to AMP 2. So this is what it will go. Then again it will be repeated. It will be repeated for next 4 records. Got it? So AMP1 and AMP2, AMP3 or AMP4, it will be repeated. So parallelly it will distribute the record. Same record, if it is, this is called indexing. Based on the indexing, one record will go to the one particular AMP. Correct? It will not go to the same AMP again. The same record is not repeating it. So it will go to the different AMP. If one record is coming here, it will go to AMP1. Next record will go to AMP2, AMP3, AMP4. Then again, AMP1, AMP2, AMP3, AMP4. It will be, again, it is not on the order. It might go to this way also. So this is called the distribution of the data. So parallelly, it will be distributed. So whenever the reading the data like AMP1, the same instant AMP4 will read the data. AMP3 will read the data. So at one single instance, the 4 data will be written. One single instance. So second instance, it will read the data. Third instance, it will read the data. So this is what 3 seconds it will process 12 records now. Okay. If it is Oracle, only 3 records will be processed. But if in Teradata, it will be processed like 12 records. Got it? This is like 1 AMP operations. Why? Because like if I'm having like the record, it will be only one the record will be stored in only 1 amp, right? It will not be stored the other amp. This is called 1 amp operations. If it is not unique primary index, you assume that if it is not unique primary index, it can have a duplicate also. It can have duplicate also. The same record can be repeated. The same record can repeated. Whatever the amp it has been loaded, the same amp it will process. It will go to again on the same amp, not on the different amp. So again, if it is record is coming the same record, again it will go to the same amp only, amp 4 only. This will be taken care by that algorithm. I will show you that algorithm. Okay, the algorithm takes place to the particular amp. It will go to the same amp. So even though it is a UPI or the PI, it will be a 1 amp operations. Got it? What is meant by 1 amp operations? So it will be 1 amp operations. The 2 amp operation will be on the secondary index. I will tell you. So now the 1 amp operations. What is that 1 amp operation now? If you look at here, the database, the primary index. The primary index is nothing but, so based on it's a mechanism to assign value to a particular amp, particular disk, the path. Okay, the access path for the particular. So entire table, it's going to be distributed within this particular amp. Okay, so while creating the table, you have to mention which is the primary index. If you don't mention, so you can have the combination of column also. So you can combine 2 or 3 columns as one particular primary index. So the combination of value will be stored in a particular amp. Only one primary index, but you can have multiple columns in the primary index. Only one primary index per table. Only one primary index per table. So primary index value can be unique or non-unique. This is the value, right? This is the value. This value can be unique or non-unique. If it is unique, then it will be a unique primary index. Okay, if it is a non-unique, it's a non-unique primary index. So primary index, we will call it as non-unique primary index also, the other word. Okay, and also the primary index value can be null. Okay, if you are making like this column as primary index, you can accept null value also, null also. So it can accept null value also. The combination of, so all the null value, it will go to one particular amp. More values coming, that is what the skewness. For example, more duplicate value is coming. Something like more this value is coming. Where all the value will go to same amp, right? All the value will go to the same amp, amp number 4.
Yes, correct.
Same disk it will go. So this is called skewness. One disk will have more value. One disk will have more value, right? This is called skewness. We will call it as tables are skewed. This is like not a skew table. Based on the, if you are not selecting the index is proper index, then see here, the record is going to the same amp, right? So this will be a skewness. We will call it a skewness. Skewness is the name, the statistical name, how the data distributed among the disk. Okay, this is called skewness. So we will come to that point later. Skewness will happen if you don't select the index is the correct index. Okay, if you are thinking that this column will have more duplicate value, you go for one more column. Okay, customer ID and mobile number. Combination of this column you create for indexing. That is why in real time they will have combination of column for primary index. So they will call it like primary index of these two columns, like customer ID, comma, the mobile number. The second column they will give. Even third column also they will give. So combination of this column will not have duplicate, right? One customer may have, if they have 2 mobile number, it will be going to the 2 different amp. It will not go to the same amp.
Yes.
So that is why the data will be eventually distributed. It will not get any skewness. If you get skewness, one amp will have more operations, then it will struggle to fetch the data and also struggle to load the data.
Yes.
So that is what the skewness. Got it?
Yes.
So primary index value can be modified. Okay. If you have already created the table, the value can be modified. From this value can update. Some other value can update it. Value can be updated. But after creating the table, after loading the data into a table, you cannot modify it. The indexing. If the table has record, right? If the table has record, you cannot, for example, first of all, you have created index by customer ID, primary index of customer ID. After some time, you want to change it customer ID to mobile number, the indexing, or combination of the column you want to create it. The only thing is you have to either you can drop and recreate, or if it is a final table, you will take the backup of the table, you will delete all the record from the table, you will modify the indexing, and then you will restore the data from the backup table to normal table. Okay, that is what you will do it. So this thing we will do it in the real time. I will show you. So this is what.
Like we cannot change the different column name as the primary index
Yeah,
without
after
drop.
creating the table, if the table
Yeah.
contains data, if the table
Okay.
doesn't contains any data, it's a blank table. Okay, you have created the table with the primary index of customer ID. It doesn't, you haven't loaded data as of now. You can modify it.
Okay.
You can
With the
modify it by
data, we
using,
cannot change the
with
column.
data, you cannot modify it. What we will do, we will take the backup of this table. Okay, for assume
And
that
we
we
will
will take the
plot the
backup of
table
the
and
table. We will,
okay.
we will delete all the record from the table. We will modify it, or you can drop and recreate also, no issues. Since
Okay.
we have created the backup, right? So after that we can create drop and recreate. We have created, and then again we will restore the data from here to here. So this is what we will do in real time. Okay. Sometimes the DBA will tell us the table is going for more skewness. You look into the issue. That's at that time you will go for the operation. And also sometimes we will have some spool space issue. I will tell you what we need to do that. But skewness, this is what we need to do that. You check the table, so how the table index has been. Duplicate record, you check for that particular indexing column. If you have more duplicate value on the particular index column, you can assume that there will be a skewness. Okay. So you have to choose some different indexing. So this is like primary index. So this is what the rules of primary index. I told, right? Employee ID will be a primary index. If you want to create employee ID alone, you can create it employee ID. Or if you want to create like a combination of the indexing, okay, like employee ID PAN number, then employee ID date of birth PAN number. It's like a indexing, okay, primary index of first name, last name, date of joining. The combination will not repeated again. The index can be divided into two different index. One is unique primary index, non-unique primary index. Unique primary in the sense, if you are assigning a column as unique primary index, that particular column will not allow duplicate. It's like a primary key. Okay, if you are assigning a column as unique primary index, that column will not allow duplicate record. So non-unique primary index is nothing but simply you are creating a primary index, right? That is non-unique primary index. So the primary index value can be null. Okay, but the index, so you cannot, if you are after creating the table, if you are you cannot modify the index. If you want to modify it, then you have to go for whatever I told, right? The backing up of the table and then also.
Yes.
So primary index, you can go up to 64 combinations of columns. Like I told, right? This is the way you can go for the combinations, like employee ID are 2 columns, 3 columns, 4 columns, right? The same way you can go for 64 different columns you can go for. And how can I create the index? So in the create table structure, at last primary index of the column names. So either one column or two column, you can go up to 64 combinations of columns. So this is what the indexing. So what is that? So significance of primary index, I will tell you the next session. How the hash value will be generated, how the data will be distributed. I told, right, it will be going to the different AMP. So how it is going to different AMP, I will tell you the next session.